Hello everyone, my name is Tianrui Guan, a PhD student at University of Maryland, College Park. In this presentation, we are presenting our work, AutoHallusion, automatic generation of hallucination benchmarks for vision language models. This work is accepted to EMNLP 2024. In this work, we want to automate the process of generating visual question pairs so that the model would be prone to hallucination. With this automated pipeline, we can tailor visual question pairs that are challenging to specific large VLMs, and the number of those difficult cases can easily scale up. Those data can be used to analyze model hallucination and mitigate it through fine-tuning based on their vulnerability. Our contributions include: we propose the first automatic hallucination generation pipeline utilizing 3 image manipulation strategies. We propose a method to probe and investigate contextual bias in language prior, which is the cause of hallucinations. We evaluate SOTA large VLMs, including GPT-4 Vision, Gemini Pro Vision, Cloud 3, Lava 1.5, and etc. on benchmark generated by AutoHallusion. It achieves success rate of 97.7% and 98.7% of inducing large VLM hallucinations on synthetic and real-world data. The intuition of our work comes from some concept in the field of cognitive science. First, I want to introduce the term schema. Schema refers to the tendency of human to organize information and interpret the world based on the pattern of past experiences. For example, it is far more common to see a keyboard and a mouse in front of a monitor instead of a cooking pot or an octopus. Creating a irregular schema can lead to cognitive dissonance, while breaking a schema result in expectancy violation, both of which can induce contradictions and discomfort in memory. We believe that human cognition and memory share certain similarity with large VLMs in this aspect. As a result, we developed 3 strategies focusing on creating irregular schemas and breaking existing schemas, which in turn lead to VLM hallucinations. Here is an overview of our automated pipeline. In the first step, we try to create a set of image and object database so that the pipeline have a list of images and objects to choose from for image editing and manipulation. Those raw data could come from existing dataset or can be generated based on specific need. The description of the things and the name of the object provides the ground truth for evaluation. There are 3 image manipulation strategies: abnormal object insertion, paired object insertion, and correlated object removal. In the first strategy, we are trying to insert an out-of-context object to create a contradiction or discomfort of the scene. In the second strategy, we find a correlated object pairs, for example, keyboard and mouse, and only insert one of the objects to the scene. In the final strategy, we remove one object from the scene that are strongly correlated with other objects within that scene. To determine which object to add or remove, we probe the large VLMs to determine what kind of object to insert or manipulate or which object to remove. Different large VLMs may have different preferences, so our manipulation is also tailored to specific large VLM. Exploring the vulnerability of specific VLM and creating tailored data could potentially be useful for further fine-tuning and improvement. The question formulated around the manipulated objects or the object of interest. We mainly ask existence questions and spatial relationship question. To evaluate and determine whether hallucination occurred, we use correctness and consistency as metrics. For correctness, it's straightforward. We evaluate whether the response is correct based on the ground truth. For consistency, we are trying to get multiple responses based on the same image and try to find the conflicts among the response. To better visualize it, here I give a few examples generated by AutoHallusion. On the left, the answer does not align with the ground truth, so we know the model hallucinated. On the right, 2 questions are asked, and the response to the slightly altered question is inconsistent with the answer to the original question. The consistency matrix is useful when we attempt to add or remove an object but failed, leading to misalignments between the image and the ground truth. Here's the result from our automated pipeline for generating hallucinations. Each of the manipulation strategies is effective in inducing hallucinations. We assess the generated benchmark based on the following three aspects. Diversity indicates the number of different scenes and objects to construct the dataset out of 200 samples for synthetic data or out of 160 from real-world data. Image quality is represented using both the inception score for both original and edited images and fetched inception distance between the original and edited images. The effectiveness is measured by the average number of questions constructed to induce hallucination. Using our automated pipeline, we create a benchmark and provide the leaderboard on a few closed source and open source methods. The benchmark dataset generated by AutoHallusion poses great challenges to existing VLMs. I would like to refer you to the paper for more results and examples. Our code, benchmark dataset, and demo is also available following this GitHub link. You can also scan the QR code for project page and Twitter posts to follow up for more updates. There are a few things to improve the current work. We plan to improve the quality of the edited image, and in addition, we plan to use the generated data to fine-tune the model and improve its performance. Thank you for your time.